In this presentation, Emily and Erin will demonstrate how to use a spectrophotometer to measure absorbance of various samples. In the first exercise, you first need to record observations of the 3 different color cuvettes. Pay special attention to the color of the cuvettes when you're doing it. We then need to set up the program to measure the full spectrum of the absorbance for these different samples. The first step is to calibrate the device, which is equivalent of kind of tearing and zeroing the absorbance spectrum. So Emily first wiped the cuvette to make sure it's clean, and then she placed it with the clear side that does not have the ridges toward the path of light. So once she started the process, you can see that the lamp has to warm up, so there's a little bit of a wait, and then the machine or the device will just be zeroed out essentially, kind of choose the unbound, but 0, 0. So now we can begin to actually measure absorbance of our samples. So again, she wipes, she places it without ridges in the light path, and then she collects the absorbance, and you can see the full spectrum of the absorbance for this red sample. Pay special attention not only to where the peak of the absorbance is, but also the shape of the graph. So is it one unique peak, or is it kind of a wider spectrum? Because all of that could have effect on your interpretation of your data when you're answering questions later in the lab. Okay, and then she's reading out the last one, and you can see the absorbance here. So the next slide actually shows the overlay of the 3 spectra for your reference. I'm just going to skip over that slide. All right, so in this next exercise, we need to use the same device, the spectrophotometer, to measure the progress of the reaction between sodium hydroxide and phenolphthalein. So the reaction that you will be observing will generate a color, as you'll see in a second when I start playing the video. And then that color will change as the reaction progresses. And because there's a change in the color, we can detect that when we measure absorbance. So as I start playing the video, the first thing we need to do is to, again, initiate the program, and then Emily will put in the necessary volumes of the reagents as specified in your lab manual into the cuvette. So she's putting some 0.25 molar NaOH into the cuvette. She's using a squeeze pipette in this case because the volume is quite large. So it would be a little bit more cumbersome to use the micropipette. Could have been another option here. So NaOH is pipetted in. And the next step to add before we add anything, we're actually going to use this just empty NaOH cuvette to calibrate our machine for our spectrophotometer. So calibration will take a few seconds, and essentially, again, this is zeroing out any contribution of absorbance from just your solvent. So we want the absorbance to be from the particles that are actually absorbing the light and not from just background readings. So we want to zero out measurement. Calibration is now complete. So now we want to add in a drop of phenolphthalein, which is what Emily will do in a second. And you'll see formation of a beautiful pink color. So the next step is to mix this to make sure that the color is uniform and your solution is uniform. So this is an important step before any reading that you do with the spectrophotometer. Then she again wipes it and puts it to make sure that the ridges are not facing the light, and reads the absorbance. You can see formation of a nice peak. So now that we have this nice full spectrum read out for our reaction, we want to actually observe changes in the reaction over time. So what we want is to select one particular wavelength that will be reading out all the other measurements at. So if I just point to this peak over here, you'll see if you kind of zoom in, or if you take a look at it afterwards when I zoom in with the video, you'll see that we're measuring absorbance on the y-axis over a variety of wavelengths on the x-axis. And you'll see that the peak happens to be at around 550 or so nanometers. So what we want to do is to select this highest peak absorbance, right? So this is the wavelength at which the absorbance is higher, and we call this wavelength lambda max, shown on the slide here. We want to select this particular wavelength, this lambda max, and then do all of our kinetic assays, the measurements over time at one particular wavelength. So I'm going to now play the video. You will see that Emily will go through the steps that are outlined in your manual in order to select the lambda max. Okay, so this is the step where you kind of point to the peak, which shows where that process where the absorbance is highest at which wavelength, and then she selected that wavelength, and now everything will be read at this 545 nanometer wavelength. Okay, so at the time we stopped the video, the absorbance of our sample happened to be 1.509 at our lambda max value of 545 nanometers. So in this next installment, what we are now ready to do is to actually do our kinetic measurements. So if you look at your manual carefully, you will see that you don't start recording measurements until your absorbance is at 0.6, right? And if you remember from the previous slide, we were at around 1.5. So we had to wait quite a few minutes before this next video installment, but you can see now the absorbance is almost at 0.6. It's 0.619. So as it's going down, when the absorbance reaches 0.6, this is now your time zero. So Aaron is now writing that down, starting his timer for 30 seconds. So after 30 seconds have elapsed, he's going to now check what the value is on the monitor and record that in the table. So a few more seconds, and then he will continue doing that every 30 seconds. So he happened to start a timer for 30 seconds. You could also have the timer going up and just look at the screen every 30 seconds to actually record the value. So you don't need to actually keep stopping and starting the timer. So the absorbance, when he glanced at it, happened to be 0.5. That was the 30-second time point. And then he will continue doing this to fill in the table for about 12 minutes or until you see that there's no longer a change in the values, so that your absorbance has plateaued. Okay, so if you're doing this in the lab, you will fill in your own values for both runs, and you'll have a full table of values. If you're doing this remotely, a table of values will be provided to you, so you can do your calculations from that. Okay, thank you, Emily and Aaron again, and that's it for this installment.